Okay, here we are in lesson 1 of the functions unit for foundations in Pre-Cal 10, and um, we're now going to define functions. Now, I don't want you to get too tied in a knot about this. It's a simpler concept than it sounds like. Okay, it sounds very confusing, but it's really not. It's just another way of looking at things that we've done for a long time. Okay, so just chill. It's okay. It'll all be all right. Okay, so we've already talked about domain and range. Domain is the possible input values. Usually we call those the x values. The range is the output values. That's our usually y values. And we're going to talk about, and we're talking about a specific type of relation, which is called a function. So these are functions here. So we're going to look at them. These are two functions, and we're going to look at them in a couple of different ways. So the first one we're going to do is this one, which is, I apologize about my pens, but they're slower on this computer. Anyway, we're going to talk about the function is a multiple of. And so what that means is that we're looking at this here. 1 is a multiple of 1. Okay, that's what that arrow means. This arrow doesn't go to 2 because 1 is not a multiple of 2. 4 is a multiple of 1, and 4 is a multiple of 2. 9 is a multiple of 1, and it's it's not a multiple of, oops, it's not a multiple of 2, sorry. But it is a multiple of 3. And then 16 is a multiple of 1, and it's a multiple of 2, and it's a multiple of 4. Okay, now I misspoke because these are not both functions. Okay, this one, in fact, is not a function. If we come over and look at this other relation, which is what I should have said before, this relation is the square of, okay, because there's only one square for each number, right? So 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and 16 is the square of 4. So this is a function because each input has one and only one output, okay? Whereas when we were looking on the other column, 16, for the input of 16, we had 3 different outputs within this, within what we were given, with the domain and range that we were given. Now we can represent these relations as set of ordered pairs. So for this one over here, we had 1 and 1, we had 4 and 1, we had 4 is the input, 2 is the output. We had 9 and 1, we had 9 and 3, and we had, it'll give us enough room here, I'll finish it over here, we had 16 and 1, we had 16 and 2, and 16 and 4. Because we can say for each of these, like 16 is a multiple of 1, 16 is a multiple of 2, 16 is a multiple of 4. When we come over to this function, which is the square of, we say 1 is the square of 1, 4 is the square of 2, 9 is the square of 3, and 16 is the square of 4. So each input maps to exactly one output. When we graph this, let's see, 1 was a multiple of all of them, so I can put a dot there. 2 or 4 is a multiple of, sorry, I spoke that backwards. So this 1 is a multiple of 1. 4 is a multiple of 1 and 2. 9 is a multiple of 1 and 3. And 16 is a multiple of 2 and 4. So that's how we can graph this. And if you can see that there are points that are stacked on top of each other on the grid, if we actually had a grid here. These are vertically stacked, and that is a feature of a non-function. Over here we have 1. This 1 is the square of 1, 4 is the square of 2, 3 is the square of 9, and 16 is the square of 4. So we each input has one output, and that is the distinctive feature of a function. Okay, so here's the definition. In a functional relation or a function, It's a special type of relation in which each element of the domain is related to exactly one element of the range. Each input has a single output. Okay, so if we're looking, explain how we define each how we determine the relation is a function. So I'm going to do this in, I'm going to reword this a little bit because I want to do this in color. An arrow diagram, I'm going to, if it, let's go. A relation is a function if, or when, with the arrow diagram, only one arrow leaves each element of the domain. Okay, so that means it looks like this. We have one arrow going from each element of it. Okay, and then I will do a non-function in red. So if I have it like this, and I have one element in the domain goes to two things in the range, that's not a function. Okay, for an ordered pair, each x coordinate has only one, should have only one corresponding y coordinate. So if I have 2 and 3 and 7 and 9, that's a function. 2 and 3 and 3 and 9. Oh, sorry, 2 and 9. It's supposed to be a 2. Because then I've, oh, sorry, that needed to be in red. Let me fix that. Okay, so 2 and 3 and 2 and 9. This is a non-function because my input's used twice. When we look at a graph, each point on the horizontal axis has only one point above or below it. Oops, ran out of space. Above or below it. So a function has all these points like that. And a non-function, oh, why I don't like this, it's so hard to change colors. Oops, okay. So if I have that, that is a non-function because these points are stacked like that. Okay. Okay. Let's continue on. Oops. Each of these is a graph of a relation. Okay, these ones here. And we want to say for these. Okay, so for each input, so looking at graph A, for each input, there is only one output. So for every point on the x-axis, we only have one corresponding y value. So that is true. And for B, that is also true. For C, that is not true, because if I look up here, I passed two places, so that's false. And for D, that is also false. Okay. For each output, you know what? This line actually doesn't matter. We don't care. Doesn't matter how many you can use. It's okay to reuse output values. Okay, that's okay. Like here, we used the 5 twice. All right, and that's fine. It's the input values that you can't reuse. And so function A, or a relation A, graph A, that is a function. B is a function. C is not. I guess it's false. And D is false. That's not a function. Okay. And looking at the next page, we're doing what it says on the next page, but we're doing it on this page. So it says, for graph C, write 2 ordered pairs which show that the relation is not a function. So for graph C, there's a whole bunch of them, but let's just go with -1. Let's go with this line right here, because that one's actually on lattice points. So that's going to be -1, -3, and -1, 3. So just going to write that here, -1, 3, -1, -3. And graph D, do the same thing, write 2 ordered pairs that show that this is not a function, and draw a line joining them. So let's go with 4 and 2 right there, or 4 and, oh, sorry, 4 and 2. I have it written down and I'm not seeing it. Yeah, 4 and 2. So that point right there, and 4 and -2. Okay, and then we can draw that line through them. Okay, so there's my point. There's my point. Let's go write that down. So we get 4 and 2 and 4 and -2. Now these two graphs happen to be symmetrical. That's not a requirement of it being a non-function. But where it says this is, oh, it says part D down here. It says on graphs A and B, draw a series of vertical lines. Do any of these lines intersect the graph in more than one point? And so no, I can draw as many vertical lines as I want anywhere on here, and I'm not going to cross my graph, my function, in more than one place at a time. Okay, and this brings us to the vertical line test, which is also called the pencil test. And let's see if I can do this with draw. Shapes. Okay, let's try that. Okay, so if I take this line and I move it, I'm going to pretend this is my, no. Okay, well, let me grab this. Okay, there. Okay, so if I grab this, I'm good. This is like my pencil. I'd be holding it up vertically in front of me. If I can run my graph all the way, or my pencil all the way across my graph without hitting anything twice. So let's do this here. If I start here and I move along here, you can see no matter where I do this, I'm only crossing my function once, or my relation once. Same thing here, I'm only crossing my relation once. Okay, so these two, A and B, pass the vertical line test. Graph C, right at this point here, I'm only touching the graph in one point. That's at the very, it's when it's tangent to the circle, it's just touching it. But in all of these places here, I'm touching it in more than one place, so it's not a function. If there's anywhere that I can be touching it in 2 places, it's not a function. With parabola here, right here at the edge, I've only got 1 point, but everywhere else I've got 2 points that are touching my line. Like my line is crossing it in 2 places. That makes it not a function. Okay, and we call that the vertical line test. So let's take a look at. I'm just going to drag this down here and grab it again, because I'm going to need it on the next page. Okay, so which of these are functions and which are not functions? So the vertical line test doesn't help for everything. It's only for when it's graphed. But let's look at this one. So this example A, each input is, oh no, the 6 is used twice. So here and here, this is not a function. Input 6 has 2 outputs. Okay, if I look at this one, this is yes, this is a function. Each input has one output. C, this is a function, yes. Each input has one output. And then if I go to D, I'm going to try the vertical line test on this one. Oops. Oh. Okay, so that point is okay, that point is okay, that point is okay, that point is not. This one is not a function. Oops, now I got to go back to the pen. No. Oh. Fails the vertical line test. Okay, and then let's go down to F. Okay, so here we go. That one's fine. That passes the vertical line test. This one, nope. We have points actually everywhere from here to here, where it's touching in more than one place. So this one is a no. Fails vertical line test. This one is yes. And then I missed this one with the connecting the provinces to the territories with their capital cities. That would be yes, that's a function because each province has one capital. So yes, this is fine. Okay. Okay, here we have mapping notation. And I just want you to, we're just going to read this. Let's just do this example here. You're going to read this as, this is function f, which takes our value x and changes it to 3x plus 1. Okay, that's basically what this notation is saying. Okay, so and this is the domain, so those are input values. So if we use this notation for -1, then this is our x value. We're taking our -1, and then we're going to do 3 times -1 plus 1, which is -3 plus 1, which is -2. Okay, and then over here, I can write it over here, 3x plus 1. So we take our 0 and we go 3 times 0 plus 1, and that equals 1. So that's going to go here. And then we have 1, and we're going to go 3 times 1 plus 1. So that equals 4. So this is going to be 1 maps to 4, and then 2. If I take 2, I go 3 times 2 plus 1. That's 6 plus 1 is, and so 2 maps to 7. Okay, so that's what this notation is using, and this notation is used in the example in the practice work. Let's just actually flip down here and take a look at that. So here's the function f. Take x, make it become 2x plus 5. So you're just going to put your x values into that 2x plus 5. Okay. So let's go back here. Let's list the elements in the range of the function. That's going to be the ones that we've written up here. So -2, 1, 4, and 7. And let's actually do that in proper notation here. Okay. If we show the function as an arrow diagram, I have my inputs of -1, 0, 1, and 2, and then my output values of -2, 1, 4, and 7, and my arrows just go straight across because it is a function, and each input maps to a single output. If I do it as a set of ordered pairs, my input value is x, my output value is 3x plus 1. So I've got -1, -2, 0, 1, 1, 4, and 2, 7. And if I were to graph it, I have to put some values on here. So I make this is 4, this is 2, that's -2, -2, Oh, sorry, my y-axis, that's going to be 2, -2. And this is -4, and that's 2, and 4, and 6, and 8. So I have -1 and -2 would be there, and 0 and 1 would be there, and 1 and 4 would be there, and 2 and 7 would be about there. Okay, there's my Cartesian graph. Okay, and we're going to that's the end of this lesson. Okay, just, you know what, power your way through it. The really important things from this lesson are that a function has, each input has a single output, and the vertical line test. That's the key takeaways from this lesson. Okay, see you in the next one. Bye.